Okay, I think everybody comes back, and let's start the second part of the organized session. And first speaker of this session, this part is the Professor Keisuke Suzuki from Hokkaido University. His presentation title is Modeling Perceptual Phenomenology of Visual Hallucinations Using Deep Neural Networks. Okay, please start.
Yeah, thank you, Hiro. So today I'm going to talk about to model phenomenology of visual hallucination. And visual hallucination is the bit related to the visual illusion, the one in Lana's talk, but it's also slightly different. So the visual hallucination is perceptual experience that occur without corresponding sensory stimuli. So people see, the object or person without basically nothing, with nothing basically. It's not like any like a seed of the image to initiate that perception. And there's basically two major type of visual hallucination. One is simple hallucination, like these geometric patterns people see, or complex visual hallucination, which is referred to lifelike images of a person, animal, or sometimes it's scenery. There are actually many different causes. Some of them are like a neurological, like Lewy body diseases, like Parkinson's disease or Lewy body dementia, or some other causes are more like just optical disease. So like Charles Bonnet syndrome, which is especially for the elderly people who losing their sight, start having these hallucinations. And also some psychoactive substances is known to cause visual hallucination. And previously we studied this visual hallucination using deep convolutional neural network. We call this platform the hallucination machine to like simulate these marked patterns of the visual hallucination. And we use, as shown here, we use deep convolutional neural network, which already learned to do the object recognition, and an algorithm called the deep dream, which basically turned the network upside down to visualize the latent space of the deep neural network. So you imagine the deep neural network, deep convolutional neural network like this, and you put the input image, and the network categorize or classify this raw image into a label. And when you train the network, we normally use back propagation to change the weight, updating the weight in this way. And a deep dream basically do the same things, but rather than changing the weight, it directly change the input image to match to maximize the neuron in the category layer. So in this way, we can actually simulate. We can actually visualize the category neuron into the image. But in this study, as you can see, there's a lot of dogs and stuff, but it's not very realistic looking, and this kind of failed to simulate a wide variety of visual hallucination. And here I just show two different major types of visual hallucination. One is the psychedelic visual hallucination. As I said, some psychedelic drug, LSD, psilocybin, or DMT, induce this kind of really peculiar color and a pattern. Sometimes they are more referred to like a visual distortion, but some people actually see this hallucination. And also these pathological causes, the visual hallucination. Pathological type of visual hallucination looks more realistic, like people actually see a person or your friend or something. So there's actually some phenomenological difference between these two types of visual hallucination. So in a psychedelic visual hallucination, characterize this as a more perceptually non-vertical, and whereas pathological visual hallucination has more vertical feature, so it looks like real, and some patients cannot distinguish them from the real object. And also in psychedelic visual hallucination is more depending on a sensory input, and neurological one or pathological one, it looks like hallucinatory image just appears without any feed. So we try to simulate these two different type of phenomenology. To do that, we use this deep neural network visualization technique originally proposed by Nguyen in 2016. And this is basically similar to the deep dream, but it's combined with the GAN type of deep generator network. So rather than directly optimize the input image in a deep dream, and in this method, the user GAN, deep generator network, to produce the image which activate most the target neuron in a higher layer. So as you can see here, the top line is the original image, real input image, and the original deep dream is like this second row. And this method can create more realistic photorealistic image like this. So we use this as a model to simulate the phenomenology of visual hallucination. So in our model, as you can see, there is a deep convolutional neural network is coupled with a deep generator network. And we take the input image as a sensory input and generated the image as a simulated phenomenology. And to manipulate the model, to manipulate the veridicality, we switch on or off this generator network. So, and note that without the generator network, it's actually going back to the original deep dream algorithm. And as you can imagine, using the deep neural network can simulate more highly veridical visualization. And another manipulation is on the selection of target neuron. So in the original visualization model, they just fix the target neuron on top-down manner. So for example, even there is an image of the bird coming into the highest layer, category layer say this is a flower. So you can actually create a hallucination based on this the predetermined category. Whereas the deep dream algorithms, they use a more loose way to select the neuron. So when the image of the bird coming, any neuron activated by the image of the bird is going down. The information from this neuron is going down to create. So there's a bit different way to define a top-down selection of the category. So we just mix these two way of manipulation to the network. So this is the result. So to simulate pathological visual hallucination, as I just said, we use both sides of the network to create a high veridicality of the image, and also using the fixed AM. So we just fix the neuron on the top layer. So in this way, we can create a highly realistic image, but the output image is different from the input image. So for example, as you can see, it's starting from the bird on the left, it's going to the flower because the top neuron is saying this is a flower. And in contrast, we can create a psychedelic visual hallucination using only the right side of the neural network, which is just the deep convolutional neural network. And that leads to the overemphasize the color and the pattern from the lower layer of the network. So this image you can see from the original deep dream network. And also just using the same deep dream activation maximization, which is basically the category of the neuron is spontaneously determined by the sensory input. So we don't really specify any target, but the bird is going to be more bird-like. But sometimes the mushroom going to more fish-like because it's drifting across the category. So yeah, this is the dynamics. The bird going to the bird, but with a lot of lower layer future space affecting the image generation. So we said this is simulating the psychedelic visual hallucination. This is a discussion, before the discussion. To validate our result, we actually doing an interview to the patient in these who sees a visual hallucination, especially for the Parkinson's disease, Lewy body dementia, and Charles-Bonnet syndrome patient. And I just showed some example from the interview. For example, this person in Lewy body dementia, he see a person on the in the bathroom. But he described the person really well, like quite detailed. And the other person also sees the London buses. They really good, how to say, identified object as reported before. So when we check the veridicality and the spontaneity, it basically according the following corresponding to our hypothesis. So in these pathological visual hallucination patients sees a really highly veridical visual hallucination. Like some people say they cannot distinguish from the real object. It's as real object. Or they mostly rated their spontaneity is really high. So it's not like a transformative from the existing object, but rather it appears with blank background. So it basically, I'll say, validating our result. And this is a discussion. So as I just reported in the interview, looks like these pathological visual hallucination patients is a highly veridical, highly realistic visual hallucination. And I think this is related with maybe this adversarial learning, get GAN type of image generation. And but same time, they see specific category. So some study shows the people in visual hallucination patients in visual hallucination sees mainly adult or human face or children. It's basically all human type of stuff. So their hallucination is not like this kind of meaningless, undefined object created by GAN. So this is just the image, sample image generated by GAN with random right-hand value. So the patient don't see this kind of abstract object. They always see some category. So it means maybe their hallucination is like constrained by categorization of image recognition or something. At the same time, psychedelic visual hallucination lacking all this veridicality seen in this pathological visual hallucination. And this is more like this, like a deep dream image. And I just always wonder why. And there's some explanation like a deep dream algorithm isolate effective cause of visual categorization. So, like these patterns are only important for categorization, but this algorithm cannot not trying to resemble the actual sensory input. So of course it's just they try to create an image which maximize the target neuron, but doesn't need to be looks like the sensory input. So maybe with this psychedelic drug, maybe the sensory perception is like trying to, how to say, not to replicate the sensory input, but rather just overemphasizing the visual feature important for perception. So this is actually very consistent with the recent empirical result. So for example, in the patient in a visual hallucination looks like having very strong prior in some experiment. So maybe it's related with a strong categorical and also generative prior. Now, also in a psychedelic state in the brain is actually opposite. So the psychedelic could lead the decrease of top-down prior and freeing up the bottom-up information flow. So it means psychedelic actually causing the weaker categorical and generative prior, which basically matching with our model. So in conclusion, our study actually not trying to study the perception objectively, but we try to simulate the more subjective aspect of the hallucination. So this is actually maybe leading the new study area for computational neurophenomenology. Thank you, that's all. And this is an acknowledgement.
Okay, thank you. And any questions? Okay, Lana, please.
Yes, I want to ask, have you ever tried to manipulate the hallucinations of somebody? So I imagine right now your system is that you have the hallucination machine and you show this to somebody who doesn't have hallucination, have you tried taking somebody who has hallucinations and put them in the hallucination machine and try to manipulate what they are seeing? And the reason I'm asking is because I have a kind of, let's say, a hallucination called visual snow. It's like some noise that you always see, and some videos can manipulate the structure of this visual snow. So I'm wondering.
Do you mean like showing the hallucination machine to the actual people, people seeing visual hallucination? We haven't yet tried, but it's really interesting, like whether this is...
For example, if I'm having a hallucination and I'm seeing a human face and you put me into the machine, can you make the hallucination disappear or maybe become something different?
Yeah, I think that's possible, because in an interview with a patient, they sometimes say like they try to hide the object in the room because you know, like some object looks like a face always triggering the hallucination, so they tend to hide you know, things in their room. So it means like yeah, some pattern might be likely to induce the hallucination more than other stimuli. So yeah, I think that's, or maybe other way around, we can maybe create a hallucination machine, but like try to suppress the visual hallucination. So that may be more useful for
that. Would be very interesting to see what kind of world would suppress the hallucination.
Yeah, maybe just disappearing everything. just a blank.
Yeah, if it's blank, I think they will have more hallucinations.
Oh yeah, of course, that's more like a sensory deprivation situation. So yeah, that's interesting.
Thank you.
Any other questions? Yes. Nathaniel, please.
Hi, yeah, I was wondering, so I was thinking, had a question all the way through, and you sort of answered it right at the very end when you said you were simulating the kind of subjective experience of hallucinations rather than the mechanism for them, or rather than the kind of objective something. But I guess what I'm wondering is, like, to what extent do hallucinatory images ever really exist? So in other words, if there's a report there somewhere about somebody who every morning sees a man climbing up a telegraph pole or something like that, right? So it could be that, like, naively anyway, I don't know anything about the neuroscience, it could be that within that person's visual system, there's just a malfunctioning neuron that's the, like, guy climbing up a telegraph pole neuron. Right, and that neuron's just firing, and that's all that's happening, right? So the guy just sees a completely normal scene, but he thinks he sees a guy climbing up a telegraph pole, and there never is an image of that, right? Or another possible thing would be that somehow the visual system does actually construct this complete image, and then that's what he sees. So I guess I'm wondering, to what extent is it known which of those it is?
Yeah, that's an interesting question, and there is some empirical study, you know, like when people see visual hallucination, even lower layer of the visual system is activated. So I think that's to me, that's a difference between like an imagery and visual hallucination. Maybe imagery just stay on a higher layer of the visual cortex or temporal cortex, but people seeing a visual hallucination may be activating the similar visual pathway. So it's quite close to the actual perception. That's why they can see really detail of the hallucination. So yeah, I think that kind of stuff we can maybe study with this kind of computational model to simulate like pathological visual experiences. So interesting.
Thanks, interesting.
Okay, any other questions? I have a short one. You just combined. Takashi, please. No, I last later. That's fine.
Well, I have a very simple question then. What do you think of this auditory hallucination thing? Is this the same thing? Because the auditory hallucination that the more people have experienced, right? I haven't experienced, you know, a visual hallucination, but the auditory one, sometimes when I got really tired, right? So
yeah. I feel that, you know, like for example, schizophrenia patients don't really see visual hallucination, but they always have auditory hallucination. I think auditory hallucination sometimes, especially for the schizophrenic case, is just the dysfunction of the cell-father distinction. So they just misinterpret the own like internal speech as a external voice. So it
I
may
see.
be different type of symptom, I guess.
Thanks. Yeah.
Okay, thank you very much, Keisuke.